with kind of best practices related to securing the DNS. So when we speak of DNS, that's the domain name system. Simply we call it DNS. So let us try to go through an overview of the DNS, or I would say even the DNS ecosystem, because there are many entities, aspects that we have to look into when you consider the whole DNS ecosystem. Now, I've just actually now have a quick sort of diagram just to give you an idea about the entities that you normally have to deal with, especially when you handle things like incidences. Because from a CERT community's perspective, I'm assuming that you have to deal with a lot of cybersecurity incidents, especially related to various aspects. And DNS is one of the very important things that you will have to deal with. Even though we don't realize that much, pretty much with everything, what we do in relation to, say, the using internet, it could be even browsing, it could be sending emails, or it could be even using mobile apps, or even say things about IoT devices and all these sort of things, right? We deal with DNS. There are a lot of DNS queries happen. So we have to understand, especially if you have to handle some abuses related to DNS, what are the entities that are involved, and also whom do you have to deal with. Now, if you consider that, say, actually try to get a laser pointer. Hope you can see my pointer here. Say, considering that you are a registrant, you could be an organization, or you could be a individual who has your own domain, or you could be an organization, enterprise who have your own domains as well. So you could be getting your domain from either it could be from a domain name reseller, or you could be going into a registrar, domain name registrar, and getting this domain name. Now, this is kind of a structure that you will find generally in DNS administration, where you have to deal with a lot of administrative contacts or matters in relation to dealing with DNS. And then also we have things called, or entities called domain name registries, or we simply call registry operators. Sometimes, these could be separate entities. Sometimes even some ISPs do these operational activities as well. So these are separate entities who actually manage the domain name registries. So they are called registry operators. And then we also have ICANN. That's what I was explaining before. So from ICANN's perspective, ICANN has got certain contracts with, say, these registry operators and some of these registrars. We call them as ICANN accredited registrars. So you can see that there are certain registry agreements exist between, say, in this case, ICANN and the top-level domain registry operators, and also some of those registrars as well. Now, when it comes to DNS, DNS is a very hierarchical system. So top of this hierarchy, we have something called root, and then we have things called top-level domains. So you are aware that there are top-level domains like .com, .net, .edu, and so on. These are actually called generic top-level domains. And then also different countries, they also have country code top-level domains as well. Simply, they are called CCTLDs, or country code top-level domains. And for example, from Sri Lanka's perspective, we have .lk, right? .lk is the country code top-level domain operator. For .lk registry is the country code top-level domain operator for Sri Lanka. So every country is given a two-letter country code. For example, LK is for Sri Lanka, or SG is for Singapore, or AU is for Australia, and so on. So there are, close to around 300 or so country code top-level domains exist in the world. And then when you talk about generic top-level domains like .com, .net, and so on, There are also actually some of these top-level domains are new top-level domains. They are called new generic top-level domains. So altogether, currently there are close to about 1,500 exist. And then, so if you take ICANN has got contracts with all these generic top-level domains, but with the country code top-level domains, we don't have such contracts because every country, they are considered as a sovereign country. So that is why they are, ICANN do not have any contracts or policy implication towards any policies upon any country as such. And then the country code top-level domain operators, they can have the policies within their own country and so on. Why I'm trying to actually explain this, because say, for example, if you deal with some DNS-related abuse, it could be, say, for example, a phishing domain or spam domain or say malware domain and so on. Then you may have to lodge some abuse report to certain parties. So you will have to actually find out exactly who the registrar, or the reseller, has actually delegated this domain to the registrant. And then you may have to actually direct or lodge some abuse report or abuse complaint to that particular party. And then if you have to do some escalations, then also you may have to actually look into these agreements they have, the other entities and the other parties, and then follow those escalation processes and so on. From ICANN perspective, ICANN also has a compliance department as well, especially to to get various sort of complaints and so on. If it is actually breach of the contracts and so on. So there are compliance matters that we do handle at ICANN level as well. But as I said, it is only with our contracted parties. Now, so I hope this has given some sort of an overview of what sort of administrative ecosystem actually exists in this space. Now, I also want to go into more details of the technical side of it. Let's say actually now, earlier I was only talking about the administration side of this. When it comes to technical side of this, say for example, if you are a user and you could be, now in this case, you are not a registrant. Earlier I was talking that you could be a registrant where you have your own domain name. But say if you are just a user that you are, you want to get into your bank website, for example, or you want to get to a certain website, then you could be sending DNS queries to certain DNS servers. Typically, these queries would go via your internet service provider or the network operator, mobile operator, and so on. But also there are some public DNS operators as well, and so you could be using some of those public DNS service providers as well. And also some enterprises, some organizations, some banks, and so on, they also run their own DNS resolution resolvers, basically, where the users can send the queries to their own resolvers, and then those resolvers would go out to various other DNS servers and find the respective answers. So the user would normally send a query to any of these DNS servers, as I told you earlier. And then those servers would go and talk to many other DNS servers out there in the world. And there are so many DNS servers. Typically, these sort of DNS name servers are called authoritative name servers, right? Authoritative name servers, because they're authorized to keep a certain database in their DNS servers. Because they are authorized for that, that is why we call those servers as authoritative DNS servers. Say, for example, if a bank is managing their own DNS authoritative servers, so they could be running their own DNS servers. If they don't want to run it, they could always outsource it to another party. So whoever it is, they have to run the authoritative DNS, and if a client want to visit that bank website, the query would initially go to the operator, the ISP, and then ISP DNS servers would go into different other name servers, and then finally would get to this particular bank authoritative DNS name server, and that's where it finds the, say, the bank website details. So that's how the usual query gets resolved here. Now, earlier I was explaining about top-level domain registries. So generally, these top-level domain registries, they maintain several databases. Now, obviously, DNS itself is a database, and it is a distributed database. So different servers, different, we keep different components of DNS in different DNS database components in different servers. So, and also there are, registries also do operate other public DNS servers as well. And then another service that they offer is actually the WHOIS service. So WHOIS is actually a public service. So this is where we register domain names. So for example, when you get a domain name, you will need to register this domain name in a public server and typically public database, and it is called a WHOIS database. In fact, actually, this WHOIS protocol is now replaced with a new protocol, and that is actually called RDAP, Registration Data Access Protocol. And so if you do a WHOIS query or RDAP query, you can find out exactly who is the custodian of this domain name and so on, and then the related details when it is expiring and this type of information. So registries would maintain this information as well. And then earlier I explained you about registrars and registrants. So this is actually, you can see that when it comes to the whole ecosystem is quite broad, and also there are many actors in this whole ecosystem. There are administrative entities, as I explained to you before. Also, there are a lot of technical, operators involved, ISPs, public DNS service operators, registrars, registries, and also, various authoritative name servers, registry operators, and so on. So it's a sort of, quite a wide scope that we have here. Now, just to explain from a database point of view, so DNS, I told you it's a database, and it's a hierarchical database, actually. And also it's a distributed database. So which means that we are not going to keep this whole DNS in one single server itself, right? It is all distributed. So in this hierarchical structure, top of the DNS is actually what we call the root. So this root is all, it's managed and coordinated by ICANN, as I mentioned to you earlier. So we have an entity within ICANN called IANA, IANA, Internet Assigned Numbers Authority, that actually is the, that is the sort of, operational arm that take care of this management function here. So then from root, these top-level domains are being delegated to different entities or different registries or registry operators. So if you take a single registry, say if you take .com, you can only have one registry that operates .com. Same way, if you take .lk, we can only have one registry that operates .lk. For example, from Sri Lanka's perspective, it is LK domain registry that take care of the .lk domain. So when I say .lk domain, that itself is a database. So they are the ones who handle .lk space. And similarly, .com, or even there are, as I said, there are like 1,500 or so top-level domains exist as of today. Now, this is also actually something which, typically when you have DNS, say domain names. Now DNS, of course, if you think from a protocol perspective, DNS was designed, back in early 1980s, long time ago. So that was when the early RFCs came, and so DNS actually queries are handled based on ASCII. So if you know the ASCII characters. So if you consider the top-level domains, these top-level domains can have ASCII characters. The names can have letters, then digits, and then hyphen. So these are the only characters that you can have for the top level domains. But the thing is that, it doesn't mean that we can only have domain names in only English language. We should be able to have domain names in different local scripts, because in different countries and so on, even to Sri Lanka, a couple of IDN domains have been delegated with different local language scripts in Sinhala and in Tamil. So that is actually, some very quick overview of the domain name system. And then from there, you can see that the next level is what we call the second level domains. The next level is called the third level, and so on. It goes all the way down. So if you want to access, say, in this case, www.example.com web server, right? www.example.com web server, we are talking about this is where that space is. This is where the label is. So we have to actually go through all this hierarchy and then get to this point where we can have that corresponding mapping of, right? So that is how the DNS namespace is organized. Now, if you notice, actually, when I was explaining that previous slide, I mentioned to you about the root. Root means top of the DNS hierarchy. So what kind of information do we have in the root database? In DNS terms, we call this as root zone. And so think of this as even a file, for example, right? So root zone or root database, so it's all the same. And what you see here is actually a small portion. What I did was I just extracted the records related to LK domain, right? So that you can relate to the local situation here. So this is the database mappings what we have in the root in relation to, say, LK domain or .lk. So what we are saying here is that if anyone want to get to LK, right, or LK domain, we are actually mapping those to some server names here. You can see c.nic.lk, d.nic.lk, and so on. So there are a number of servers listed here. So that means if any query, if any query that gets to root will be directed, or root will give a reference to and talk to these name servers listed here, like c.nic.lk and d.nic.lk and so on. But obviously, DNS is in a very high layer of the TCP/IP protocol, but the actual data communication happens in the IP layer. So IP layer means actually the IP addresses, basically. So we have to map these names to their corresponding IP addresses. That is what you see here in the bottom, where you will see the different kind of IP addresses. Some IP addresses are IPv4 addresses, whereas some IP addresses are IPv6 addresses. So these are different versions of IP. And so this means actually when earlier I was telling that if you want to visit a certain website, your query goes to your ISP DNS server, and then your ISP DNS server goes and talk to the root name server, right? The root, access the root database, and then it finds that, okay, if they want to find LK, these are the name servers that it should go to, and then those name servers are located in these IP addresses so that we can get into these LK domain servers and try to ask the same question, give me the next level or the second level, right? So that's how the queries get resolved. Don't worry about some of these, there are different other characters here. These are all related to security because there are some signatures later. I'll explain you how you can protect this data using cryptography, basically. So that's where actually you'll see some signatures here. Because if you do not protect this data, there can be a lot of abuses and attacks can happen. So I hope that you got an idea about the root database. So next thing is actually, where should we keep this root database? Now, if we keep the root database in a one single server, that is not secure at all, because if that server is being attacked, or if there's some DDoS attack, if that root, if that single server goes down, then the whole DNS will go down. So that is why, but of course, it has never happened in that way. And we have, this is why we have many root servers exist in the world. So currently, I mean, just I took this snapshot today in the morning. So as of today, you can see there are 1,329 root server instances scattered around the world. So these are all different places. It doesn't mean that everything is concentrated into one place here. It is just the region. That's why these numbers are. So you can see that 1,329 root servers or root server instances are scattered around the globe. And so if, say, for example, any of these root name servers, out of all these, any of these root name servers, they keep the same database. I showed you that database earlier for LK records. So in all these root name servers, the LK records looks the same because the root database is all the same across all the root name servers. So just imagine now, if you do not have some root servers near you, right? So say, for example, if you are talking from Sri Lanka's perspective, if, say, around this area, if there are no root servers, our queries will have to go further away from Sri Lanka to somewhere else to access the root. Actually, many years ago, this was the case. And for example, I mean, I was involved in deploying some of the root servers in Sri Lanka. In fact, actually, when we deployed the first root server in Sri Lanka, that was back in 2008. So before that, there were no root server instances in Sri Lanka. So the queries had to go all the way from here to outside world to get that resolution to the top level domains. But when we start having root servers in Sri Lanka, we saw that there was a big improvement in terms of DNS response time. And so I will try to now zoom into, say, Sri Lanka's perspective, because here we are talking from Sri Lanka's perspective. So you see that there are 7 root servers actually in Sri Lanka. If you further zoom this out, you can see that they are identified by different letters. So these are all different servers managed by different operators. And I can also manage some of these root servers as well, basically operate some of these root servers as well. So, so the whole idea here is that actually there's a lot of resilience here. There's a lot of security here, because even if one of these root servers fail, it doesn't mean that the internet would go down, or that's you wouldn't really notice that, because the queries can still go out. Even within Sri Lanka, there are so many, there are a number of root servers as well. Even if 1 or 2 goes down, still there are other root servers that can handle these queries. So I hope that you got some idea about even the root servers as well. So even from root, it is very important that the security and stability and the resilience, even from top of the DNS, which is root, is very, very important. Now, when it comes to the query or as a DNS as a service, how the queries gets resolved. And so say you are a client, right? So you have your mobile phone, so you want to actually start a mobile app, for example. So as I told you earlier, we always use DNS, even when you open your mobile app, there is DNS query that goes out. And then, so we have something called a stub resolver, which is actually in your operating system itself, whether in your phone or in your laptop or in your operating system, basically. And then, so that will, if, say, for example, if you want to access a certain website, or you want to use a certain mobile app, we have to get to that server. That means we need to know that IP address. So that is why this client or the resolver has to send a query to your recursive resolver, which is basically your ISP or mobile operator, or that public DNS service operator that I told you before. So they will, I mean, that server, that resolver then would go out to various authoritative name servers out there in the DNS. So these could be even, say, for example, this could be a root server. And then root server would say, go and talk to, say, .com server. And then .com server would say, go and talk to, say, example.com server, right? So that's how it goes all the way based on the hierarchy, root, top level domains, second level domains, and so on. It goes based on the hierarchy. And then this recursive resolver is able to go and talk to all these authoritative servers and find the exact answer. Answer means the IP address related to the domain that you want to visit, or the website that you want to visit, and get that IP address, and then it will be given to the client. So once client gets that IP address, client can go and visit the web page, or basically connect to that server. But then one important thing that the recursive resolver does is that it will cache this information, means the IP address information. So caching means it keeps that answer in the memory. So why it is keeping in the memory? Because if this client asks the same question again from this server, this recursive resolver doesn't need to go and talk to these root servers and top level domain servers and so on again and again, because answer is already in the memory, and then straight away from the cache, the answer can be given to the client. So this makes the DNS responses much faster. So that's how the DNS queries gets resolved. So even if you want to go to any website, or you want to send email and access more apps and things like that, this is how the DNS queries gets resolved. So now let's talk about some of the threats and abuses exist in this space. Now, when we actually have our domains, right? So when you deal with DNS, I told you that a lot of people don't really think about the how important it is, because DNS can expose a lot of information about several things, say about your organization. So this could be about your organization domain name, right? So your organization domain is there, and then your different host names within your domain, right? So you could be having your web servers, different other hosts. So these are all there in the DNS. And then various IP addresses, because these hosts, they have IP addresses, right? Your mail server IP address, your web server IP address, or various other servers and so on. And then your various other servers, as I said, like mail servers and things like that, were very important. And then various database servers, their locations, what are their domains and things like that. So these are various sort of information is exposed in a sense, like this information is there in the DNS. So this is why you really have to protect DNS. I mean, I told you that earlier that a lot of organizations, they don't really deal with DNS. They could be subcontracting the whole thing to a third party to look after their DNS. Even the domain name renewals, buying the domain name, renewing the domain name, dealing with the registrars, or dealing with the registries, and then all that, and then managing servers and all that can be outsourced. But it is always good to have some idea about what they are supposed to do and what they should be also doing, and whether they are doing the right thing and so on, right? So when it comes to domain name registration, it is actually it is prone to attacks, because it is a very attractive targets for the cyber criminals and so on. Domain registration. There are several reasons for this as well. One thing is there are a lot of automated processes happen nowadays, because, for example, that you don't have to have a physical person to actually register a domain name. It could be done by a bot, for example, right? So that whole registration process can be handled by an automated process. And then registrar correspondence with the registrants largely through emails mostly, right? So this is mainly because even probably, if, for example, if you already have a domain name, you know that when you correspond with a registrar, you mostly correspond using emails, right? So if your email is compromised, then say an attacker could actually impersonate as your registrar, for example. So you could be talking to some attacker thinking that it is your registrar. So this also, could be a problem. And also, a registrant is responsible for the registration data accuracy. So it is the registrant who is responsible to update the domain name servers. Earlier, I was explaining about the authoritative name servers. So if, say, you have your own domain and you have your authoritative DNS servers, and you are supposed to update this in the registrar's database or the system, as we discussed earlier. Now, it is your responsibility to update this, right? So in case if some attacker get hold of this information, say get your credentials to the registrar system, they can remove your name servers and they can update that with their name servers. So whatever the query is intended to you will go into the attacker. So these kind of things can happen. It does happen very often. And also, one of the other problems is also there are a lot of inexpensive registrations. There are a lot of these. There are some, in fact, free registrations. Some registrars would even offer, okay, for the first year we would give you free registration, and then next year onwards you have a small fee or something like that. I mean, this is good for consumers, but also it is good for the attackers as well, because if there are a lot of free services, if there are a lot of cheap services, they could go and they could register domain names only for a very specific purpose. It could be just for an attack, it could be just for a malicious purpose, to run some malware or to run some botnets and things like that. They may not need it for a whole year itself. They may only need it for a short period of time. And so that free service would be fine for that time duration. So this is also why actually DNS can be a very attractive, or the domain registrations can be an attractive target for the attackers. Now, when it comes to a lot of these malicious and misused domain registrations, it can happen in two ways, of course. One is an attacker can purposefully register a malicious domain, right? So purposefully in a sense like this is exactly done for a specific purpose for an attack. I mean, they would control the infrastructure. They would buy the domains, right? They would probably use a stolen credit card, and then they could buy the domain. So this is one way. And the other is they could use someone else's legitimate servers for their purpose. So you could be running your own DNS servers or own domains and so on, and you're using it for a legitimate purpose, and you have properly paid and things like that and so on. So attacker would just compromise into your servers, and then rather than they buying all these things, they could just use your servers for their purposes. So this is also kind of misuse as well. So this is through this, there are so many different types of attacks do happen, abuses do happen nowadays. There's a whole list, but I've just only put few which are kind of popular. Phishing is quite popular. There are lots of phishing sites. These sites looking exactly like, say, it could be your bank website, it could be a social media website. It could exactly look like that, and then user is being basically taken into this wrong place, wrong web server, and then user would think that, oh, it's the real site. A lot of users actually, don't, when they go to website, they may not really observe the domain. Actually, they may not observe the domain. They only see the look and feel. As soon as when you get to a website, it looks like your, say, social media site, or the interface is like the bank website. They may try to give your credentials, ID, passwords, and so on. So you may not really, the users may not really particularly look into the domain, or whether it's an IP address, or whether it is a real domain, or things like that. So phishing attacks are very often. And then business email compromises. Again, a lot of business email compromises happen because even as you know, even in an email, you have a domain as well. So if some attacker can actually compromise a certain domain, the emails also can be compromised. Mail servers can be compromised as well. So in this way, a lot of these there are a lot of criminal infrastructure can be out there. It could be your name servers, it could be your mail servers, it could be your domain itself, and all, these things can be actually abused. Many of these domains can also use to run malware as well, malware infected sites. There are even malware command and controls. I think over the last few days, probably there must have been several discussions in relation to a lot of these malware botnets and things like that. So I don't want to go into too much details here. So these things exist. And then cache poisoning. So cache poisoning is also something quite important. Important in the sense like this is a big threat that we have. So which means earlier I was talking about, say, your DNS server managed by your ISP or the resolver. So these resolvers can be poisoned. So earlier I was telling that it keeps the IP address answer in the memory. So if, say, if I am your ISP's DNS server, if you want to get to your bank website, you send me a query, and then I would go out to other DNS name servers, and I try to find the IP address and give it to you. But this IP address, I'm keeping it in my cache or in my memory. So if my cache is polluted, if my cache is poisoned, which means if some attacker managed to change that IP address in my memory to something else, something controlled by the attacker, then obviously next time you ask me anything about that bank website, I'm going to give you a wrong answer. So then you will go into a wrong website. So these kind of things are quite often. And then man-in-the-middle attacks. This is also, where the queries can be hijacked in the middle. So there are lots of DNS threats and abuse exist. DNS attack space is very large and very complex. So this is why it is very important that you should pay attention to your DNS. By design, DNS protocol itself, I told you that it was designed back in early 1980s or so. So there were, a lot of these security mechanisms were not there in the DNS protocol by design itself. So we have to implement these protocols separately. And say, for example, if you want to have data integrity, say if I am a DNS server, and if I'm giving you a response, you don't know whether that response is modified in the middle, right? So the data integrity has been lost. So if you have to ensure the data integrity, you have to have some security mechanism for that. In the same way, query response confidentiality. In terms of DNS privacy, that's a separate area as well. So usually when you send a DNS request, it goes in clear text. And so if you want to have DNS privacy, you still have to have some mechanisms to do that, for us to do that. And then there are namespace risks. Now, if you actually look at these two domain names, one is example.com, and then the other one is also actually, it looks like example.com, but you can see that E is a different homoglyph. Homoglyph in a sense, it's a different character. It's not really English. It could be from a different language. But it could still, for the user, it could still look the same, right? Even though, if you have these two domains in a browser URL bar, it's not visible really. It looks the same, right? But actually, it's two different domains. The later, this domain refers to this, so it's a totally different domain, right? So this is also why when you have to deal with that internationalized domain names, as I told you before, you also have to be careful because these kind of attacks are also very, you will see quite a lot nowadays. There are things related to typo squatting, because sometimes when we type domains, we just, maybe it's just a typo, we just, rather than typing example, we just type that in this way, right? M and A is swapped. So someone could just take this domain and then still pretend to be that exact domain. So they might have a website exactly looking into the same domain that you wanted to go. So you might still think that you went to the right place, and you might try to give some credentials, that you have. So these kind of things are quite common. And then what else? There are things called redirections. So this is where your domain name servers can be redirected to a separate server. So attacker can gain control and then point you to a different place. So your query will go to a wrong place. Resolve the hijacking. Now, earlier I was telling you that when you want to say visit a certain website, your query goes from your device to your ISP, for example. And but how do you know whether it's really going to your ISP? It could be going to some attacker's DNS server, right? Because ultimately that is the DNS server giving you the answer so that you're going to go to that website. So you have to, obviously you have a trust with your ISP, so it is fine that you're getting the answer from your ISP. But we don't know exactly we are getting that from our ISP. This is what we call resolve the hijacking. This happens in various ways as well. Say, for example, you could be initially through a spam email or something like that, the attacker will let you go into a malware infected website. And then once you get into the malware infected website, you would download that malware, and then the malware is able to change your DNS settings. If the malware change your DNS settings, currently your DNS settings are directing to your ISP, but if the malware managed to change the DNS settings into the attacker's DNS, then obviously all your queries now will go to the attacker. Sometimes when we go out in the public, right? Say in public places, in restaurants, in train stations or in airports and things like that, we see lots of free Wi-Fi hotspots. And when we see some free Wi-Fi hotspots, a lot of users tend to connect to these free Wi-Fi hotspots. But how can you trust those? Not really, right? So we don't know exactly who is operating that infrastructure. If you can trust, that's all fine. But if you don't have that trust, then you could be actually sending all your DNS queries to someone else who could be running this resolver. And then if you're doing some transactions, or as I said, some important banking transactions and things like that, these things could be vulnerable. And also they could know that what websites that you are visiting and so on. Denial of service, or simply what we call DDoS type attacks. I think you may have discussed this earlier, so I wouldn't really want to go into too much details, but especially if any ISP community is listening to this presentation, if any operators are listening, when you run your DNS resolvers to your customers, to your clients, make sure you have some access controls. Don't let anyone query your DNS servers, because your DNS servers should be queried only by your clients, only by your customers. Because if you open your DNS servers to whole world, these sort of DNS servers are called open recursive servers or open resolvers, then you are giving attackers the opportunity to create more DDoS attacks as well. There are millions of open recursive servers out there in the internet, and then all these DNS servers can be contacted, and then responses can be redirected to innocent victims, innocent web servers, and create DDoS attacks. So denial of service also quite a lot in the DNS space. Impact of hierarchical namespace. So which means if the attacker managed to compromise the higher layer, so say for example, if the attacker compromised the TLD, then as we know, DNS is a hierarchical space, so everything below is kind of compromised as well. And also, say you have your domain, say if you have your domain example.com, if your example.com domain is compromised, or if the attacker got control over that, then they have control over all the subdomains, right? So you could be having a lot of subdomains as well. And then there are lots of other threats related to the compromises of registrants, right? So I gave you some examples before. Make sure you have proper secure interfaces to your registrars. When you update your registrar, your name server details, your DNS related information, make sure that you have proper secure interfaces, right? Use things like SSL, TLS protocols and or even use things like VPNs and so on, right? So in these ways, you can at least, you are logging into your system securely. Registrar compromises can happen as well within the registrar. So even if you do your updates properly, if the registrar systems are compromised, then still you could be in trouble as well. Not only you, even the other domain holders could be in trouble as well. So even from registrar's point of view, if there are any ISPs here who are offering any registrar services, I think it is also very important for you to consider that, make sure that your registrar systems are quite well secured as well. Registries can be compromised as well. If the registries get compromised, then the damage is much more severe, because there are lots of domains registered under that, and then also there are lots of registrars talking to these registries to update databases and so on. So the damage is much more severe. But obviously, when it gets to registry level, they have a lot of mechanisms in place to ensure the security. But as users, mostly what we have to deal with is mostly our side, registrant side. DNS software vulnerabilities, especially when we use a lot of DNS software and so on, make sure that up-to-date versions are all running, because there could be some vulnerabilities. As a good practice, if you run multiple DNS name servers, try to have some different DNS name server softwares across those. If you use only one software across all your name servers, then you have a high chance, in case if there is some vulnerability, then you might actually, in all your DNS servers could be in danger as well. So in general, try to summarize the things that I was talking. There are a lot of potential target points in the DNS ecosystem that we discussed. We talked about many areas in DNS. We talked about client, stub resolvers, client devices, recursive resolvers managed by operators like ISPs and so on. Then we talked about authoritative name servers that generally you manage. Say you could be enterprise, you could be a government entity, you could be a bank, you could be any organization. You could be having your own domain infrastructure, right? So you have to make sure that all your authoritative name servers are well secure, and when they communicate between each other, they are all secure as well. And then when you talk to registry systems, registrar systems, those systems are also secure. The protocols are secure. The interfaces are secure. So we have to think about that option as well. And from registrant point of view, the interfaces also should be secure as well. As I said earlier, when you update your name server details, you have to make sure that you have proper security mechanisms in place. Now, this is just to actually some best practices. Just want to give a list. I wouldn't want to really go into details of everything, because it can include a lot of technicalities. But in general, if there are some technical people involved, if there are some ISPs, or if there are some domain registrars, domain operators involved, these are some things that you may consider. The first point that I have is something called deployment of DNS security extensions, or simply called DNSSEC. So DNSSEC is a security mechanism that can give you integrity and authenticity of DNS data. Earlier, I was telling you that if I give you some DNS data, how do you know whether this data is not modified in the middle? And then also, if I give you some DNS data, how do you know whether it's really coming from me? Someone else could be impersonating me. So DNSSEC can address these issues, and it can protect the DNS data. Earlier, when I was showing you that root zone, I told you there are some signatures, right? I showed you there are some signatures. So this is where those signatures would come into the picture. So when you deploy DNSSEC, what you are really doing is you are digitally signing your DNS data. So if you have a web server record that is already been digitally signed, so when the client is given that record, we make sure that it is not tampered in the middle, and the IP address is not really changed in the middle, and so on. We are giving the right information. Secure user interfaces, I think we talked about that. Registrar locks, especially if you are managing your own domains, try to discuss, with your registrars and registries, and have these registrar locks, because if you have registrar locks, when you say, for example, if you want to move from one registrar to another registrar, um, then you will be informed before transferring the domain. If you don't have registrar locks and so on, an attacker could really, without you knowingly, they can even transfer your domain to another registrar, and they can take control of that. So just imagine you are a big bank, and then if your domain is compromised, and they have even transferred that to a different registrar in another country, and then you could be having a difficult time in getting back that domain, and because it's all gone. So having registrar locks is also very important. And then to have some proper monitoring and diagnostic tools, and have that monitoring within your network, within your DNS, is also very important. Network and server redundancies. So that's quite a lot in this area as well. Make sure that when you have your DNS servers, don't put all your DNS servers into the same IP address block, right? Because some organizations, when they get the IP address blocks, they try to put all the name servers into the same prefix or same blocks. Don't do that. Because in case if that prefix or that block is being attacked or compromised, then all your name servers are being compromised as well. So try to separate into different networks, even physically. Try to separate those into different physical networks as well. Don't put all your DNS name servers into the same rack inside your data center. If all your name servers are in the same rack, in case if there are some physical disasters, it could be fires, it could be floods, anything, right? Natural disasters can basically take out all your name servers. So have different data centers. If you have, say, one authoritative DNS in one city, have the other authoritative DNS in another city, right? So try to have that separation. So always, redundancies, network server redundancies are very important. And then when you have multiple DNS servers, when you transfer your databases, earlier we talked about DNS databases, make sure that proper secure transfers are being done. There are lots of access controls we can introduce. We can do a lot of key-based authentications. When you go into details, especially if you are into a lot of DNS administration, we can talk about this. Feel free to even talk to me later. Happy to assist you in these areas. Authoritative servers must answer authoritatively. Because authoritative servers are not supposed to be giving recursive queries. Earlier, we had differentiation between DNS servers called recursive DNS servers and authoritative DNS servers. So authoritative DNS servers should only answer authoritatively. We should not do recursion in authoritative servers. In the same way, recursive DNS servers should only do recursion, but have some access controls. And earlier also I was telling that if, for example, if you're an ISP, make sure you have you're giving your answers only to your clients. So have some access controls there. If you get some queries from other IP blocks or outside your customer blocks, you should not give the recursive responses. Updated DNS software, we talked about that. Make sure you support all the technical standards and compliance. There are lots of, when we buy products, when we buy third-party products, software, hardware, and things like that, make sure they comply with the standards. Things like, even I was talking about DNSSEC, that's a compliance as well. Try to have these standards as well. Know your SLA, especially maybe some organizations here, you have outsourced your DNS to other parties, right? Third parties. You are not doing your DNS, but you have outsourced. But make sure you know your SLAs, service level agreements. In case if your DNS is attacked, if your DNS goes down, what sort of service level agreement that you're going to have, and can you still serve your customers, users, and so on. And then make sure you have your proper plans in place to deal with attacks, and test those regularly. That is very important. We can all have plans, but if you don't test that, then we cannot really ensure that it will work, right? Just like, taking backups, things like that. So basically, good cyber hygiene is very important. And I think DNSSEC, I already talked about it. Basically, what we're doing is to ensure the authenticity and integrity of DNS data. So DNSSEC is a very important keyword that you can even think of this, and later you can look into this. Typically, in the past, with the SL cert and so on, we try to do some workshops as well along this DNSSEC. So in case if any organizations are interested in deploying DNSSEC and so on, feel free to talk to me, and always very happy to support you, help you. I think that basically winds up my presentation. This is what I wanted to convey. And so you have my contact details there as well. In case if you have any questions, I can take some questions now. Otherwise, we can talk later.
Thank you, Champika. I think that was an amazing session. You spoke to us about the overview of DNS ecosystem and security. I think you spoke in a very layman language. I'm sure that it was quite helpful to most of the participants over here. You touched upon country level domain, generic level domain, and more importantly, we spoke about how DNS get resolved from users' computers to it get passed on to ISP and other DNS servers. Then we came to a point where you mentioned about WHOIS, which is more interesting. Now, when it comes to CSERT and law enforcement authorities, WHOIS tool plays an important role. But due to the GDPR, we've had issues now. Sometimes when you try and query and see the registration of certain domains, unfortunately, you're not able to obtain certain information. So what's your thoughts on that? I mean, it has made life of, especially this, I would say the law enforcement authorities a bit more difficult at times. I mean, these were handy, you just query and you get the information within seconds. But due to the GDPR, there has been some restrictions.
Yeah, that's actually, now there are two aspects to this. Because obviously from you have to think from users' privacy perspective as well. At the same time, there's the law enforcement perspective as well. So there are two aspects to that. So obviously from CERT perspective, law enforcement perspective, yeah, when you do a query, say for example, when you do a WHOIS query, you may not get the say things like registrant's name or contact details and things like that. But there are certain processes actually within even things like GDPR, or even for that matter, there are many other countries now, they are coming up with their own data protection laws. There are some provisioning that for law enforcement, there are some sort of escalations that they can do within their role. And also, actually, this is also why earlier I was telling you about the new protocol, which is RDAP. So with the RDAP, there are a lot of provisioning where when the law enforcement or when the those sort of committees, CERT, and so on, when you do the query, your output could be different to the normal user's output. So with RDAP, there is that provisioning as well. So and also there is a lot of this whole discussion is ongoing. And I would also encourage you to actually participate even within actually ICANN. In fact, this whole meeting, we had an ICANN meeting as well. ICANN, we have 3 meetings annually. And within ICANN, we have a community called Public Safety Working Group. I mean, that's a working group. So there are lots of law enforcement agencies, lots of security communities and so on. They are also involved in this working group, public safety working group. And I would also encourage you to follow some discussions, and if the law enforcement, say for example, in this case, Sri Lanka law enforcement, if they want to, I know that I have also been working with some of the law enforcement as well in this regard. So if they want to actually provide some, say some input in say what sort of difficulties that you have and things like that, these are proper forums that they can bring this up and then discuss, and then the policies can be worked upon.
Thank you, Champika. That's a good point. I think something that we would also look into. You also spoke about DNS being in a hierarchy distributed systems. You spoke about top level, second level, and third level domains. We also touched upon root servers and the number of root servers located around the globe and in Sri Lanka. And also then we moved on to DNS threats, the different cache poisoning, phishing, DDoS, redirections. I mean, there's so many, typo squatting, and so on and so forth. Then we also finally touched upon the best practices. You also highlighted a point to the service providers, making sure that the DNS query should be resolved, only the customer's query should be resolved, and that should not be open to public. I think that is an important point to be taken. You spoke about best practices like DNS security and also service level agreement, especially if your DNS is being outsourced. And I think that is somewhere that where we have seen a lot of problems in the past, because we tend to sign an SLA, but then we don't see actually what's in the SLA, and by the time you encounter a problem, it becomes difficult to go back and fix the damage. So I think again that's another important fact. With that, Champika, let's move on to some questions, if that's okay by you.
Sure.
We've got a few things lined up, and I think some of them you answered, but let me just read it out to you. First thing is, some of them are interested in your PowerPoint slides. So
Yeah, I can share that. Yep.
Right. Okay. Thank you. So guys, that can be shared with you all. So how long would it take to update all DNS in the world?
How long it takes to update?
Correct.
It's in the first place, the DNS data is not in a single place, right? It's all scattered around. That's why we have a hierarchical system. So different parties manage their own DNS. So let's consider, say, your organization perspective. Say your organization is example.com. I'll just take example.com, right? So that is your organizational domain. So if you want to update some certain records, say tomorrow you want to update your web server IP address, right? You want to port your web server into a different server, and then you got a new IP. So say you change your ISP. And so you need to actually pay a lot of attention, because earlier I was telling you about that DNS caches, because earlier your information about your website IP address has gone out to DNS, and they are in DNS resolver caches. So say the early IP address is, I'll just take 1.2.3.4, right? So that is your previous IP address. And say you want to change it to 5.6.7.8, that's a new IP address. But before you changing that new IP address, make sure that that old IP address has cleared out of the caches. And in DNS, there's something called TTLs. TTL stands for time to live. So you have to exactly see what are the time to live values. Say, for example, if your time to live values are like 1 day, right? So that means when the answer goes into a cache, it will be there for 1 day. So you should not change that within the day, because if you do that within the day, say someone might not be able to visit your website, and so you should allow at least more than that TTL time for safety reasons. I think it's good to have twice of your TTL, so that you can do that change. So it all depends on the TTLs, or the time to live values. And also, one of the other aspect is also something that you may want to consider, especially if you're running your own DNS. I told you about authoritative name servers, because if you have multiple authoritative name servers, they also have between them, they also have something called refresh time. Because if they work on that refresh time, if, say, for example, you have two servers, if one server goes down, all the queries will be actually taken by this second one, right? So that is why the second one, or the secondary server, would always come and talk to the primary server based on this refresh time, right? So you say, for example, if this secondary server, and the refresh time between the primary server and the secondary server, say 1 week, for example, right? I'm just picking some numbers, right? If it is 1 week, sometimes the secondary server then will not come to the primary server for the next whole week, right? So even if you, after your TTL, say within 1 day, you still change that information, but you have to understand that this secondary server is still having some old information. So which means whoever party is contacting this secondary name server will still get the wrong information. So this is why actually you have to analyze exactly what sort of timings are there in these timing parameters, and then do changes and so on. So to answer your question, there's no exact answer that how long it will last. It all depends on TTLs. It all depends on those timing parameters.
Thank you, Champika. And also in DNS cache, what is the size of the cache space? Because so many info needs to be saved, which comes from the world. Also, is there any time period after the data will be deleting automatically?
Yeah. So actually, it all depends on, of course, your memory, right, and then the server resources. Um, so if you are the administrator, say if I am the administrator for example.com, I can decide how long my records can last in caches. So it is my decision. So I can decide if I want, or if I know that I'm not going to change my records for very often, right? Every day I'm not changing my records, then easily I can put a TTL of 1 day because I know that every day I'm not changing it. And but if you're having a very busy zone that you change the things very often, then you might want to even further reduce that. So it all depends on your requirement. There's no any specific value as such. It is up to you to decide as the DNS administrator. You can decide how much of TTL that you want to put.
Thank you. Can data be stolen when we just visited without even entering any credentials, a website with a malicious domain?
So if you visit a malicious domain, obviously, if the attacker has control over that malicious domain, say if the attacker is running the web server, if the attacker is running the DNS and so on, then obviously even say they have access to your information, what you enter. For example, they could, if you are entering some credentials, they could store that in a database, for example. This is what happened in phishing sites, right? Usually, they would create a similar-looking bank website, and then they would store your credentials in a database, basically, and then they just cut off, and then they've got your credentials, basically. So it's up to the attacker; they can do that. But say again, one important thing I want to highlight here: when you visit a website, you have the protocol, which is HTTP and HTTPS, right? So HTTP is HTTP without S, right? So that means it's not encrypted. So which means if you are, say, if you're going to do some credit card transaction, or if you're going to give some credit card details and things like that in a site which says HTTP, right? There's no S. Don't do that, because whatever the information that you give, your passwords, your credentials, your credit card details, and things like that, it can be seen in clear text, right? So if someone tap the wire and basically they can see all that DNS, basically the traffic. And so this is why it's very important that if you're going to a certain say secure transaction, you have to make sure at least you have HTTPS, that is SSL or TLS, basically, that is encrypted. But again, it doesn't mean that it is the full solution for that, because these SSL certificates can also be compromised as well. They could, because there are thousands of SSL certificate authorities that can give these certificates. So you might you might go to a cheap SSL certificate authority and then probably get a certificate for quite cheap, and they may not offer a good service. But then it all depends on how reliable they are. So this is also why I was actually trying to mention you earlier. Implementing things like DNSSEC will again add some extra layer to this. You know that you're going to the right place, and you can detect these issues.
Thank you. And what is a subdomain takeover attack? What is the reason behind the attack and how to prevent?
Yeah. So now I also mentioned you that if your domain is compromised, say if I have example.com, if example.com is compromised, anything below example.com, say test.example.com or anything.example.com is compromised. So they have control over that, right? And then so they can get control over that. So this is why actually you have to be very careful, especially when you are accessing your registrar system. Make sure that credentials are not open, keep it secure, things like that. This is very important. And the other thing is also sometimes they may get hold of your main domain, say example.com, but they may not do anything for that. I mean, you might think you're all fine, safe, and everything, but they can have maybe inside a subdomain, right? Inside, say, test.example.com, inside that, they can have a malware site, for example, right? So without you knowingly, they can still have some subdomain inside your domain.
Thank you. It says that farming attack is something like poisoning DNS and directed to some crook's website. Does this DNSSEC prevent this sort of attack?
Yeah, DNSSEC prevents things like cache poisoning, phishing, those kind of things that I mentioned to you earlier. DNSSEC prevents that. So that is also why I was just trying to tell you that it's very important that if you can deploy DNSSEC, especially given that the amount of abuses, attacks happen nowadays. But also at the same time, you should also take into the point that deploying DNSSEC does not mean that your DNS is fully safe either, right? Because you have to think it as a whole ecosystem. That's why I was trying to explain the whole ecosystem itself. It's not just only the authenticity or integrity part or protecting DNS data. You have to think of other aspects as well. Even things like physical security is important. Who is having access to your DNS servers? Even physical access, who has access to your server room, things like that. These are all important. Also, I think from a security point of view, it's very important that you should have a security policy in your organization. If you don't have any security policy in your organization, maybe you can start from today. Start it small. You don't have to have a very, fancy, nice, sophisticated security policy. You can start very small, add few things, like email policy into that, add some other physical security policies into that, and then you can review and have a good security policy for your organization.
Thank you so much, Champika Wijayatunga. I think you answered all the questions. Thank you so much. And the final note that you gave in terms of policy, I think that is very important. And we've seen a lot of organizations out there without policy at all. And some of them do have, but then the employees do not know where it's located, or they've never read such a policy. And some of them don't have a policy. So like you said, it's always good to start somewhere. Create something on your own. You don't have to follow ISO 27001. You don't have to start off there, but then to start off something and slowly build up, which can eventually take you to the standards that you're looking for. So let me thank you once again on behalf of Sri Lanka, sir, for being with us this morning with your all busy schedule. You've never said a no to us on any of the program that you requested to be part of. Thank you so much, and we do appreciate your time. Thank you. So with that, let me inform the audience that this comes to the end of the first session of day 5. We've got another interesting session this afternoon. So email communication plays an important role for business organizations. I mean, even personal for an individual. So we're going to speak about. We've got experts from Interpol and another sector. They're going to talk about business email compromise, which is a pretty much interesting and a hot topic in today's world. So please join us at 2 p.m. this afternoon. Let me not forget to thank our sponsors, Cisco, for providing such an amazing platform for making us, administrative tasks so much easier. Dialog Mobitel SLT for making the data charges free for all our constituents. So thank you so much. Let us not forget to thank Soteria, who will be providing us the Hacking Challenge platform on the 28th. And those who have not still registered, and if you are still interested, please do visit our site, www.sir.gov.lk/CSW2020, and register for the Hacking Challenge. We also have a few workshops coming on next week. So all the information are available on our Facebook and our site. So with that, thank you so much. And I hope to be connected again at 2 p.m. this afternoon. Thank you.
Thank you all. Thank you. Thank you all.